Welcome to Tennessee's at-home learning series for literacy. Today's lesson is for our 8th grade students, but anyone is welcome to tune in. This is the third lesson in this week's series. My name is Mr. Ayers, and I am an 8th grade teacher in Tennessee schools. I am so excited to be your teacher for this lesson. Welcome to my virtual classroom. If you didn't see our previous lessons, you can find them on tn.gov/education/pbsteaching.html. That's a lot. Let me say that again. tn.gov/education/pbsteaching.html. You can still tune in to today's lesson if you haven't seen any of our others, but it might be more fun if you go back and watch our others lessons, since today we'll be talking about things that we have already learned. Today we'll be continuing about real-life body snatchers. Before we get started, to participate fully in our lesson today, you will need paper, pencil, and a surface to write on. It'll be helpful if you can have the student packet for ELA Grade 8 Lesson 13 that can be found at www.tn.gov/education. If you can't get that packet printed off, don't worry about it. I'll be going through things slowly and I'll repeat things so you'll be able to participate. Are you ready? All right, let's begin. So today our goal is to read the informational text called Top 10 Real Life Body Snatchers. We have already started this text. We're just going to keep looking at it and digging deeper and go through more of it so that we can analyze that information in the text to determine its meaning. We'll begin with me reading a portion of the text, and then we'll reread it and pause along the way for a deeper understanding. At the end of the lesson, I will assign you independent work that you can complete after the video ends. Speaking of which, if you tuned into the previous lesson, you may have completed the independent work assigned at the end of that one. Remember, I asked you to write a summary of what you read about the hairworm and the cricket, and to use these words in your summary. Parasitizes, hijack, ingest, exposed, and subsides. So take a second to look at what you read and read through that. Take about 30 seconds. Okay, so here is what I wrote. When a cricket ingests a hairworm or takes it into its body, the hairworm parasitizes the cricket by hijacking its central nervous system so that it can control the cricket's behavior. The hairworm makes the cricket go to exposed water out in the open. Once the hairworm comes out of the cricket into the water, either the cricket dies or its strange behavior subsides and it goes back to normal. Was your response something like that? Now, it could have been different, but I hope you got those words in there and remembered some of those interesting details about how the hairworm takes advantage of the cricket. So let's now dig into that informational text we're going to be studying today. This is just another section of that same article about the real-life body snatchers. As a reminder, Historically, people who were called body snatchers were people who stole dead bodies from graves in order to study them or sell them. But these aren't that type of body snatchers we're going to be reading about. We're going to be reading about certain types of parasites or living things that survive by using or hurting other living things, which we call hosts. As a reminder, we'll be hearing a lot of scientific names in this text like Paragordias tricuspidatus from the previous lesson. Don't worry about understanding or remembering them. Just know that they're names that scientists use to refer to different species. I'll be clear about what we're referring to. Yesterday, we looked at the introduction and certain words and phrases that will help us understand the text. This text has 10 sections total in it. One section on each real-life body snatcher or parasite. Today, we will study in depth the second and third sections. As a reminder from yesterday, we'll use the information we learned today to complete the Venn diagram on the article. If you don't have your Venn diagram out already, go ahead and take that out. All right, so let's take a look at what we have so far and what this Venn diagram looks like. So this Venn diagram shows some of the things parasites do when they infect their host. Some change body features, some use chemicals and venoms, some lay eggs in their host, and many do a combination of 2 or even 3 of these things. As we read about different parasites this week, we're going to be sorting them into various sections on this Venn diagram. For example, if we read about a parasite that uses venom and changes body features, but it doesn't lay eggs, we'll put this in the upper left-hand section where the circles overlap to show that it's in the chemicals and venoms and changing body feature circles, but not in the laying egg circles. If we read about a parasite that changes body features, uses chemicals or venoms, and lays eggs, we'll write its name in the very center. Don't worry about this just yet, though. As we complete this exercise towards the end of the lesson, we'll be very specific about where it needs to go. Just go ahead, if you don't have this diagram, draw it on your paper. Be ready to use it in the class. Make sure that you go ahead and put that hairworm and cricket in the section of chemicals and venoms. Remember, we said that the hairworm affects the chemical makeup of the cricket to make it change its behavior. So let's begin the text. I'll begin by reading a section of the text about parasites and their host. We will then reread the section and analyze it on a deeper level. As I read the text, please take notes on your paper. Try to focus on the relationship between each parasite and its host and write down key details about them. So, some of these words are hard for me to pronounce, so I'm probably going to stumble over them a little bit. So just bear with me as I pronounce these words. Are you ready? All right, let's begin. Look, I've even taken notes on how to pronounce them. Hymenopithecus argyrophaga, one of the most complex manipulations or changes of a host by a parasite, happens in Costa Rica. A female parasitic wasp of the species Hymenopithecus argyrophaga stings the spider Plesiometer argyra and paralyzes it. In the 10 to 15 minutes that the spider is immobilized or not moving, the wasp lays an egg and affixes it to the spider's abdomen or stomach. Wow, that is a sting. Notice that the female wasp that stings the spider, that's going to be important later. So let's keep reading. For a week or two, the spider proceeds living as normal. So it's only a temporary paralysis, meaning the spider is only paralyzed for 10 to 15 minutes. When the spider is down, the wasp lays an egg, remember it was the female, and sticks it to the spider's stomach. The spider just carries on like normal for a week or two. Then the egg hatches. The larva or young wasp pierces the spider's tough skin and sucks its blood for sustenance. So now the egg hatches and the young wasp emerges. Instead of leaving, the wasp stays and sucks the spider's blood. But why? The sentence says that it is the wasp larvae that sucks the spider's blood for sustenance. Based on the context of the passage, what do you think the word sustenance means? So take a second and write that word down on your paper and write down what you think the definition is. So based on the passage, it sounds to me like the larva is consuming the spider's blood to stay alive. Kind of like we eat food to stay alive. For humans, sustenance is things like bread and vegetables rather than spider's blood. Let's see what happens next. On the night it plans to kill its host, the wasp larva injects a chemical into the spider that drugs it into spinning a web unlike any it would normally make. Basically, the spider repeats one stitch in its web constructing repertoire over and over. So let's look at a challenging word in this section before we discuss what it means. Listen to these two sentences again. On the night it plans to kill its host, the wasp larva injects a chemical into the spider that drugs it into spinning a web unlike any it would normally make. Basically, the spider repeats one stitch in its web constructing repertoire over and over. Based on the context clues, what do you think the word repertoire means in this context? Take a moment, write that word down on your paper, and try to define it. So, the key detail I noted in these sentences is the phrase spinning a web unlike it normally would make. Then the passage says that instead of doing what would normally do, it repeats one stitch in its web constructing repertoire over and over. So it sounds to me like the spider has a whole toolkit of web making strategies it normally uses, but in this case, it only repeats one stitch over and over. Therefore, a repertoire is a set of skills that a person or thing uses often. If you play a musical instrument, for example, your repertoire might be all the different songs that you can play. If you like to cook, your repertoire might be the different dishes you can make. If you play a sport, your repertoire might be all the different plays that you're really good at and you like to do. For the spider, its repertoire is different types of webs it can make. So why did the spider not use his whole toolkit or his repertoire of web making strategies? Well, because it was drugged. Before the wasp larva kills the spider, it drugs it. So it'll only make that one stitch over and over. It's all part of the wasp plan. I wonder why the wasp makes the spider make only that one kind of web with that repeating stitch over and over. Let's see. The wasp larva then kills and eats the spider, spins the cocoon from the sturdy web, and a week and a half later transforms into a wasp. Okay, so the wasp clearly needed a sturdy web and had the spider repeat a stitch over and over so it's thick and strong. Once the web is in place, the wasp larva kills the spider, eats it, and then a week and a half later transforms itself into a wasp. Okay, that is not a very kind thing in this situation, is it? Is it? The spider gets, he's the host for the larva, for the egg. The larva then sucks the blood from it to eat. And then when it gets ready to go to the next stage, it shoots venom into the spider, drugs it so that it spins a web specifically to help the larva wrap up into a cocoon to become a wasp. That's a pretty vicious little wasp there. Okay, so let's take a step back and go through those details. Remember that when it's ready to kill the spider, what does that parasite wasp do? Yeah, it injects a chemical into the spider. And that's what makes it actually start doing that particular web. It needs that cocoon so it can transform into an adult, kind of like a caterpillar transforms into a butterfly. So can you picture all that? So just remember that it injects with a chemical. Do you have any key details in your notes about the parasite wasp and its spider host? If not, just take about 30 seconds or so to write some notes down. So I wrote in my notes that the wasp lays an egg on the spider. The larva that comes out of the egg injects a chemical into the spider, and that makes the spider spin a cocoon for the larva. In addition to all this, the wasp larva sucks the spider's blood and eventually eats it. Pretty good deal for the wasp, I'd say, though not much for that spider. So now let's add our notes to the Venn diagram that we've been working on this week. You already have out your copy, so let's take a look at it. Okay, so I know that you may not have the text right in front of you, but I think your notes will help. Take a moment now to think about where the parasitic relationship we just read about would fit into this diagram. Okay, I'll show you where I place this one and you can see if it matches up with your thoughts. If I included information that is not on your Venn diagram, please add to it. So I put wasp and spider where the chemicals and venoms and laying egg circles overlap. I'm going to make sure that I leave room for additional answers to be added later. I place this parasitic relationship between the wasp and the spider into the space that overlaps chemicals and venoms and laying eggs. Because remember that it was the parasitic wasp who stings and paralyzes the spider with a drug to make it spin a web for the larvae to use as a cocoon. The drug counts as a chemical or venom. I think, and of course, we know that there's also an egg involved. So this parasite fits into both circles. Is this where you put it on your diagram? If not, take a moment and add it to your diagram. All right, great. Now let's move on to the next example of a parasitic relationship. As I read, listen closely and take notes regarding the key details. Glyptopantales. Little do caterpillars of the moth Pharyntina leucocephala know, but as they feed on guava and eucalyptus trees in Brazil, the larva of the parasitic wasp of the genus Glyptopantales may very well be feeding on them. The wasp deposits up to 80 eggs in the caterpillar. So that's kind of a crazy thought. While the caterpillars are eating trees, the larvae of the parasitic wasp are eating the caterpillars and laying eggs on them. And there's 80 eggs. This one is starting off interesting already. When the eggs hatch, the larvae bulk up by eating the host inner parts. At full size, all but a few squeeze through holes in the caterpillar's skin and spin a cocoon on a nearby twig or leaf. So now all 80 of those eggs are hatching and the larvae bulk up by eating the host inner parts. I know that bulk up means to get stronger, to get muscular. So clearly the larvae are growing and getting stronger by eating the insides of the caterpillar. Then it says that once the larvae reach full size, all but a few are squeezing through the holes in the caterpillar's skin so they can spin a cocoon. But what happened to the few larvae that stayed behind? Let's see. The larvae that stay behind begin to pull the puppet strings, so to speak. Within a day, the caterpillar stops eating and starts exhibiting a strange behavior, what scientists call violent head swings. Notice that the author says that the parasitic wasp pull the puppet strings of the caterpillar to make it protect the cocoon. Take a moment and write on your paper what you think the phrase pull the puppet strings implies about the wasp's actions. Okay, so when we're looking at the phrase pull the puppet strings, we know that the author is not using a literal phrase, as that does not make any sense in the context of the passage. The author is using the phrase figuratively or in a non-literal sense. Authors often use figurative language like this so that you'll paint a picture in your mind of something. Did you pause and imagine in your head a wasp pulling the puppet strings out of the caterpillar? What does this say about who is in control of the caterpillar's actions? Right, the wasp is, in a certain sense, pulling the puppet strings by making the caterpillar do things against its will. So what is the caterpillar doing against its will? It stops eating on the trees and starts swinging its head around violently, which means really fast and aggressively. So let's keep going. Like a bouncer at a bar, it swings at any predators that approach the cocoon, either knocking them down or causing them to back away. Once the wasp emerge, the caterpillar dies, having served its purpose. So now we know the reason why the wasp is making the caterpillar swing its head around like a headbanger. It's trying to keep away enemies. This allows time for all the wasps to emerge and keep living. It has a sad ending though. The caterpillar dies. So let's review this information. Make sure that you have this as in your notes. The caterpillar of this moth species likes to eat on certain trees in Brazil. What they don't know is that a certain kind of wasp likes to eat on them while they're eating on those trees. The wasp then deposits a bunch of eggs in the caterpillar. When the eggs hatch, the larvae get stronger by eating up the caterpillar's inner parts. Some leave the caterpillar, but some stay behind. The one that left the caterpillar are making a cocoon nearby. The ones that stay behind, they make the caterpillar stop eating and start swinging its head violently to ward off anything that might eat the young wasp. They basically make it their own personal security guard. Take a minute to Check your notes, write down anything that you may have missed. Okay, now let's add what we've learned about this parasitic relationship to our Venn diagram. Take a moment to think about where the parasitic relationship of the caterpillar and the wasp might fit into this Venn diagram. All right, so I'll show you what information I identified, and you can see how it matches up with your thoughts. If I include information that is not on your Venn diagram or in your notes, please add to it. What I noted from the parasitic relationship between the wasp and the caterpillar, I think it goes in the same place that we wrote earlier, the one that overlaps chemicals and venoms and laying eggs. Here is why I added this. The parasitic wasp lays eggs in the caterpillar, and then after the eggs hatch, some stay to pull the strings or to make it protect the cocoon. I put this example here as I infer that the larvae is using some type of chemical to control the caterpillar and make it protect the cocoon. Did you have it here in your diagram? If not, take a second to change it or to add to any of your notes you might need to. Okay, so that's all the details I'm going to add today, but I'm looking forward to reading about more of these relationships tomorrow so I can add more details. Make sure you hold on to your Venn diagram so we can reuse it. I hope that you have found this exercise helpful. The purpose is to make sure we are categorizing the examples and ideas we have read about today, as well as observing the relationships among them. So finally, let's kind of reflect on today's lessons. Today, we learned about some parasites and the creative ways that they take advantage of their host. For your independent work, I want you to respond to the following prompt. In a brief essay, compare and contrast the parasitic relationships we discussed today. What are the similarities between the wasp and the spider relationship and the wasp and the caterpillar relationship? What are the important differences between them? Be sure to use specific details from your notes to support your answers. Take a moment to write down that prompt. Great. As you're doing that, I don't want you to get too hung up on, oh my gosh, I don't have enough details written down. Just really try to just put your thoughts into some coherent paragraph form. That'd be perfect. Wow, we really learned a lot about those parasites today. It was actually pretty interesting. Thank you. I enjoyed working on the body snatchers information with you. Thank you for inviting me into your home. I look forward to seeing you in our next lesson in Tennessee's At Home Learning Series. Goodbye.